welcome to the module on the concepts of queuing theory. Myself, C. Priyadharshini Infanta, Department of Mathematics SF, Nirmala College for Women. I am here to present some of the basic concepts of queuing theory. What is queuing theory? Let us move on to the definition of queuing theory. Queuing theory is the mathematical study of waiting lines or queues. A queuing model is constructed so that queue length and the waiting time can be predicted. The queuing theory is generally considered a branch of operations research because the results are often used when making business decisions about the resources needed to provide a service. Characteristics of queuing system. Some of the characteristics of queuing system are arrival characteristic, queue characteristic, and the service facility. Let us now look into the arrival characteristic. The arrival characteristic, in which the size of the arrival population, it can be either finite or unlimited. The distribution, in which the size can be fixed or of random. The arrival rate is the rate between two consecutive arrivals or individual arrival. The arrival always follows a Poisson distribution and it is denoted by the letter lambda. The various types of customer behaviors are balking, reneging, jockeying, and priority-based customer behavior. Let us first look into the concept of balking. What is meant by balking? Here, the customer sees and leaves the queue, not entering the queue, seeing the size of the queue. Since the queue size is too long, he does not even attempt to enter into the queue and he leaves the queue as soon as he sees when the queue size is too long. The next one is reneging. The customer waits in the queue for a certain time and after which he sees the queue is too long and his service would be late, so he leaves the queue. This type of concept is known as reneging. Jockeying is the switching between two queues, wherein he stands in one queue and he looks on to the other queue, seeing which he moves to the next queue thinking that he would get his service faster, and from there he is switching to the other queue. So such type of switches from one queue to the other queue is known as jockeying. Priority-based customer behavior, in which the customers are served on the basis of the priority. If there is any work which comes with a high priority, the other works are kept aside and the work with the highest priority are taken first and completed. The queue discipline. So whenever a customer enters into a queue, he follows certain type of queue disciplines. So some of the queue disciplines are given below. The first one is FIFO, which is first come, first serve. The customer who arrives first is getting served first. On an example, on an average queue, normal queue, the customer who comes first gets his service done first and leaves the queue earlier. The next one is LIFO, last in, first out. The example of last in, first out is when you arrange a certain books on a line or inside a box. The book which we have kept at the last would be taken first. So this is the example wherein the queue discipline follows a LIFO process. Next type of queue discipline is selection in random order. On a random order, the customers or the priority jobs are selected and they are served first. The next one is the priority based queue discipline. The jobs or the customers with the high priority are served first rather than the other type of customers. Next one is the service facility characteristic. The service facility characteristic depends upon the number of servers. The server may be 1, 2 or infinite, and the number of phases which are required for the service. The distribution here is often an exponential distribution because depending upon the arrival, the service is being done. So the distribution here which is followed is an exponential distribution. This denotes the time taken for one server to complete his task. Usually in queuing characteristic, it is denoted by the letter mu. Queue performance. Certain type of queue performance are there which are needed for the calculation of the queuing model. So first, let us look into the row which is known as the utilization factor. The utilization factor is calculated by dividing the arrival process divided by the service time. So on which the arrival is denoted by lambda and the service is denoted by mu. So on the whole, rho is equal to lambda divided by mu. LQ denotes the average number of customers in the queue. It denotes the average number of customers in the queue excluding the person who is being served. LS denotes the average number of customers in the system. In the system denotes the person who is being served as well as the person who is standing in the queue. The next one is WQ. WQ denotes the waiting time of customer in the queue. Here also the waiting time is calculated excluding the person who is being served. WS, the waiting time of the customer in the system. We also consider the customer who is being served as well as the customer who is in the system. And P0, when the probability that there are 0 customers in the system is denoted by P0. If you want to calculate Pn, which is the probability of n customers in the system, we use Pn, and n varies accordingly to the probability of the customers. The basic Kendall's notation. So putting all these concepts together, Kendall formed a notation wherein depending on this, the models have been derived. The model goes like A/B/C D/E, where A is the arrival process, B is the service time distribution, C is the number of servers, and D the total population, E is the queue discipline. Let us see with an example wherein I have taken the example of the model 1 m/m/1 infinity slash FIFO, where the first m follows the arrival process and the second m denotes the service time distribution or the inter-arrival distribution. 1 denotes that there is one server in the system, and infinity denotes the population size is infinite. That is, any number of customers can arrive in the system. And the last one is the queue discipline, wherein the first comes customers should be served first and they have to leave the queue. So based upon this, we can change the number of servers, the total population, queue discipline, the arrival pattern and the service pattern, and form the model according to our convenience, deriving all the queue disciplines and all the distributions which we have given first. Based upon this, we can find out LS, LQ, WS, WQ and row, and tell a customer about the waiting time that he has to wait in the queue, or at what time a system can be served. So with these basic concepts, we conclude today's module. We can look into the detailed queuing concepts, and depending upon that, the models can be derived in the upcoming video. Thank you and a happy learning. Thank you.